Good afternoon and welcome to this webinar titled Magnetic Gear Simulation in SolidWorks. My name is Arvind Krishnan, and on behalf of EMWorks, I thank you all for being present today for this webinar. I will be your host today. Just before I start, I have a few bookkeeping items. The first thing that I would like to let you know is that this webinar is being recorded and a link will be sent to your email. So in case you miss some parts of this webinar or you want to revisit them, it is always going to be there. And this webinar will also be in our YouTube channel. The next thing that I want to let you know is we're going to use the GoToMeeting to do this particular webinar. One of the features of GoToMeeting is that there is a chat box that allows you to type in the questions that you wish to ask me. So please use your chat box in case you need to ask me some questions. And I will, at the end of this webinar, answer some or all of your questions. Also, just as a courtesy for other participants, if possible, kindly mute your microphone. With that, we can start this webinar. So let us briefly look at the agenda that we have for today. I'm going to introduce the topic magnetic gear. Then I will quickly move on to the EMS interface inside SolidWorks, where I'm going to be showing you a product demonstration of a particular magnetic gear design. And then we will take a look at the EMS product bundles that we have. Then we will quickly recap what we have seen today. And last but not the least, I have a colleague from the sales department joining in today who will talk to you about our offer for the COVID-19. So let me start with a magnetic gear. I'm pretty sure all of you know a mechanical gear and you see them commonly used in a lot of machines. You can even see them in bicycles and in clocks, etc. Now, magnetic gear is no different from a mechanical gear with respect to its performance or with respect to what it is set out to do. Basically, a gear is a way by which you can transfer power from one rotating element to another. So it's basically used for power transmission. Now, in mechanical gears, you have teeth which meshes, and then two teeth are in contact with each other, and then the movement of one of the gear produces another movement in the gear that is in contact with the moving gear. In the case of magnetic gears, we don't have tooths. Instead, we have permanent magnets at the periphery of the gear elements. You notice here I have an image that shows you permanent magnets which are attached to the periphery of the gear, and the blue ones could be having a coercivity direction or a magnetization direction which is different and opposite to the one that you see as red. Now when you bring these two magnetic gears close to each other, and when you rotate one of the gears, the other one will also rotate because of the property of permanent magnets and how the fields interact with each other. Now to simulate such magnetic gears, we can use EMS in SolidWorks that can accurately predict the torque performance of these gears. And I'll be showing you a small demonstration of one such design. So basically, magnetic gears are a way of achieving contactless power transmission. They employ permanent magnets, basically neodymium based magnets that enable you to achieve this power transmission. So what are the advantages of such a setup? As you can see that there is no contact between the two gears. As a result, there is no friction, and hence the heat produced due to friction is virtually absent. Because there are no contact points, it produces less noise, and the vibration is also less compared to a mechanical gear. Overall, it presents a very clean operation because there is no need for lubricants, etc. So if you are looking for applications in the electronic industry which requires these gears to be used in inside clean rooms, etc., these are excellent choices. It protects against overload because the gear easily slips when one of the shaft is overloaded. And finally, it provides a constant power ratio, which could become an advantage or a disadvantage based on the application that you are looking at. Now let us look at simulation of magnetic gears. Now we have two options for the simulation of magnetic gears. You can do these magnetic gears as full 3D simulation, or you can do them as a 2D simulation. Now, because these magnetic gears have a planar symmetry in them, in that the magnetic field does not vary if you take one section along its thickness or another section along its thickness. So this particular phenomena can be exploited, and you can actually use a 2D magnetic simulation to solve problems involving magnetic gears. And that's what I will be showing you today, how you can actually do these things inside SolidWorks. Now 2D simulation will solve this particular problem because of the planar symmetry accurately, and it will solve it at a time that is a fraction of what it would take in case you do a 3D simulation. EMS as a product handles both 2D as well as 3D simulation. Okay. So EMWorks 2D is the product that's a part of EMS which handles 2D simulation, and it offers planar symmetry, which we will see in this particular example. It also offers 2D axis symmetric simulation. It supports the following studies: magnetostatic, transient, and electrostatic. And it is capable of doing a fully parametric simulation. Now let me move on to the software demonstration of a magnetic gear. As I mentioned earlier, I'm going to be using the 2D simulation inside EMS for SolidWorks to do this. We're going to do parametric simulation, and the objective of the study is really to understand the magnetic flux density and how does it change when I change the inner rotor position, or if I rotate one of the gears, how does my magnetic flux density plot changes. And the most important is, how do I measure this torque as a function of inner rotor angle. With this, let me bring SolidWorks into the picture, where we are going to take a look at the magnetic gear. Now this is a magnetic gear that was created inside SolidWorks. It's actually a 3D model, and the 3D model is very similar to what you see here. This is the same model that I'm going to be using. Now we are going to do a 2D simulation. So EMS has some tools to actually automatically convert your 3D models to 2D. And these tools are found under EMWorks 2D top folder item. For example, we do have a feature called 2D simplification, which allows you to simplify your 3D models automatically so that they can be used for 2D simulation. So we used such a technique to actually create this 2D model that we will use for the study. Now, the first step that we did is to create a 2D magnetostatic planar symmetric study. Let us take a look at the study properties. Now you see the study properties as the following tab. In the first tab, we have checked the parametrization. So this enables us to parameterize any SOLIDWORKS geometry dimension or any simulation variable as a parameter. In this particular example, we will use the angle between the two gears as a parameter. Next, as I said, the 2D EMWorks 2D has two different types it can resolve. One is the planar symmetric 2D model, other is the axis symmetric 2D model. This particular example is a planar symmetric 2D model, and usually models that have constant thickness and the field variation across one cross section and the other is uniform. There is no variation at all in the field, no matter what cross section you take, then these kind of problems are suitable for 2D planar symmetric. If your model is axisymmetric and your fields are also axisymmetric, then you can use the axisymmetric solution type. In this particular example, the gears have a length or the thickness of 1000 millimeters, and that is one of the inputs that we need to supply to the solver. Once we create the study, the next step involves applying materials to the various components. Now, if you look at the inner rotor is made up of a steel rotor as well as permanent magnets which are attached to this steel rotor. Now you can easily define materials from the EMS material library that you see here. So you can actually, EMS comes with a predefined material library that you can use to readily define your materials. This material library is completely customizable, so you can actually create your own materials and use them for simulation. In this particular example, I've used steel 1008 for the rotor and N35 magnet. Next, let's look at these modulators. Basically, these modulators are steel that serves as a conduit for carrying the flux from the inner rotor to the outer rotor. Without the modulators, you will have to keep a very small air gap, and that makes it very impractical to manufacture these gears. So we can take the use of the modulators and keep a sufficient air gap between the two gears, and it can still function well. And this is really the job of the modulator. In some designs, you won't find the modulators, but in that case, the air gap is also minimized, giving it a very tight tolerance, and your manufacturing capability must be equipped to handle such tolerances. So usually in large gears, you do find these modulators. Next, we have the outer rotor. The outer rotor is also made up of a lot of these N35 magnets and 1008 steel rotor. Once the materials have been defined, the next is to define the direction of the magnet. So let me open one of the magnets in the inner rotor to tell you how to define the direction, north-south direction for a magnet. So in EMS, it's extremely easy. We have this dialog box that allows you to define the coercivity direction. You need to select a coordinate system, and you can use both Cartesian as well as cylindrical. In this case, these magnets are radially outwards or inwards, so it makes a lot of sense for us to exploit this cylindrical coordinate system, whereby we can easily specify the direction for each of the magnets. Once the materials have been defined, what we need to do is to compute the torque. So here we request EMS to compute the torque on all the outer rotor elements as well as to compute the torque on all the inner rotor elements. If you recollect, our objective is to study how this torque varies with the inner rotor position. Next, we do a parametric simulation whereby I keep the inner rotor angle, which is a geometry parameter created inside SOLIDWORKS, as a parameter, and I vary this angle all the way from 0 degrees to 45 degrees. So we're going to move this particular gear, the inner gear, and give it a rotation of about 45 degrees, and we're going to capture what happens every 2 degrees. So a parametric simulation is a nice way of being able to produce this effect. Now I've actually run this simulation prior to this webinar, so we can go straight away into the results. Now EMS gives you a plethora of result options to view what happens in your model. So you can actually take a look at the magnetic flux density. Here is a magnetic flux density plot in the gear. So as you see here, this plot tells you the regions of high magnetic flux density and also gives you the magnetic field lines superimposed. So this gives a very clear picture of what happens. Now there are some air geometries that I have not shown here, but I'm going to create another plot of magnetic flux density without superimposing the magnetic flux lines. There are some air geometries, for example, the air gap, where I can show this and then create a new plot to see the magnetic flux density in also the air region between the two rotors. Now this plot gives you the magnetic flux density including the inner air region. You also have the ability to superimpose these plots with a contour plot of the magnetic flux lines. So you can select the magnetic flux lines option, and this contour plot will be superimposed by the magnetic flux lines. So if you zoom in, you can actually see the flux lines and you can see what happens in the moderators. You can see it serves as a conduit for transmitting the flux from the inner rotor to the outer rotor. You can also see areas of high saturation where you can measure the value of the magnetic flux density right from the chart. Now next, we will take a look at some of the quantitative results that you can get. For example, we wanted to get the value of torque for both the inner as well as the outer rotor across all scenarios. So one can do that by creating what is called as a 2D plot. Notice the torque values stays almost steady depending on the and is independent of the inner rotor position. So, and this gives you the ratio or the gear ratio between the two gears. So EMS can readily compute the magnetic field as well as can give you the numerical value of the torque created in this magnetic gear. Now these values can be readily listed and you can export them into text format or Excel format, making it easy to further process your results. So because this is a simulation that was done as a function of position, we also have can create what is called as a AVI to see how the movement of the gear happens. So here I'm just playing an a video file that shows you how the movement of the gear happens. Basically, we are animating all the scenarios and I've captured it in a AVI file, which I'm playing. So EMS has the ability to capture these animations as a video file and you can save them as a video file. So really, this is what I had in mind for you today in terms of the demonstration. We looked at how you can create a 2D study from a 3D model seamlessly in EMS. You saw how the workflow is very similar to the 3D workflow. If some of you are have knowledge about it, you create a study, you can parameterize SolidWorks geometry parameters, you define materials, then we define the directions for the magnet and we request the program to compute the torque acting on both the inner rotor as well as the outer rotor. And in terms of results, we can get qualitative results such as the plot of the magnetic flux density. We can look at the magnetic field lines. And finally, we can see how the torque value varies with the parameter that we chose. In our case, the angle. And last but not the least, we can create an animation file of how the flux lines change as you change the parameters. So with this, let me move back to my presentation and then talk to you briefly about the product bundles that we offer. EMS comes in two different product bundles. We have the EMS electric bundle and the EMS magnetic bundle. And both the EMS electric and EMS magnetic bundles actually can do both 2D as well as 3D simulation. In addition to these bundles, EMS comes with a variety of add-on products. We can couple EMS to thermal analysis. We can couple it to motion analysis, linear static stress analysis, and also circuit coupling. So these are some of the coupling analysis that comes with the main EMS bundles. And there are other videos talking about other aspects of EMS in our video library. So if you're interested, you can check out our YouTube channel which has a lot of videos talking about various aspects of EMS. Next, let's just quickly recap what we saw. It's extremely easy to create and simulate magnetic gears in EMS. Both 2D as well as 3D simulation is possible. And for magnetic gear type of application, the 2D handles the geometry very well without any compromise in the accuracy. And it is extremely fast to do a lot of simulations in a small amount of time. We can make use of parametric simulations that allows us to parameterize any SOLIDWORKS geometry as a parameter. We can also set as parameters any simulation variables such as current, frequency, etc. And finally, the EMS product bundle that you need to be able to do magnetic gear simulation, as I showed you, is just the EMS magnetic bundle. Now, before I go, I just want to bring our website and show you the application note corresponding to the magnetic gear simulation. Our website emworks.com. If you go to the application section, we have a plethora of application notes that you can see to see how EMS can suit various applications. I go to the magnetic gear section, and here I have the application that I showed you. So we have a write-up and also contains all the um, finer details that we might not have covered in this webinar. So feel free to take a look at this application note and also the application notes section of our website so that you can get to know more about our products. Now I would like to uh, bring my colleague from the sales department, Cal, who will talk to you a little bit about the COVID-19 promotional offer that EMWorks has.
Thank you, Arvind. Hello, everyone. I hope everyone is doing great and staying safe. My name is Cal. I am from EMWorks sales team, and today I'm here to give an important announcement. For the last 25 years, EMWorks has helped its customers around the globe to develop some amazing products, and our commitment to you has never been stronger than it is today. We understand that COVID-19 has caused a huge impact not only on human lives but also economy of our countries. We also understand that many employees are working from home and companies are facing cash flow restraints. We have seen many prospects of ours who were looking to invest in simulation software but could not do it because of cash flow restraints. During this time, to ensure productivity of our customers and prospects, we are introducing this special promotional offer. As you can see on the screen, all the registrants and attendees for today's webinar with valid business email addresses and who are interested to evaluate and buy our product can now avail 3 weeks of full version trial license with technical support and 30% discount on EMS software. This software is valid till end of May, that is May 29th, 2020. Please review this offer and feel free to contact us at the given email addresses. I will also personally send you this promotional offer information via emails. Thank you very much and stay safe.
Thank you, Cal. And finally, On behalf of EMWorks, I would like to thank you all for attending today's short session. For more details, you can visit our website, and all the information regarding contact is present in this slide. We have our YouTube channel where there are over 100 videos showing various aspects of EMWorks products. You can also join us at the various social media platforms that are listed here. With this, if there are any further questions, please use the chat window and I'll be happy to answer them